Let's make a couple of more points about the critical issues in land mitigation. Land availability and indirect land use are the two critical ones, as I mentioned. You can put that in the context of biofuel to reduce emissions, the energy consumption being higher for richer people, but that could affect land availability and land use for poor people. How? For example, there is the competition between using food products, grains, etc., for biofuels versus food itself for staple for poor people. And this IMF calculation shows that this is still true. This is a little bit old, but nonetheless, this is from 2011, I think. If you look at the percentage of income spent on food, so per capita income versus percentage spent on food, as the per capita income goes up, like richer countries like UK, US, and so on, the percentage of their income that goes into buying food reduces. In other words, poor people spend a larger fraction of their total income on just meeting their nutritional needs or food needs. Okay, this makes it very critical for how we use food grains and land for bioenergy without affecting the food security and hunger and vulnerability and other issues for the poor people. When we think about land use change and carbon fluxes, for example, under the Paris Agreement, there have been nationally determined contributions that countries have committed to. We will look at one of the examples from India and China and other rich countries, not other rich countries, India, China, and the rich countries. You have to find a formal way of monitoring the actual progress on those things, and that's the same in terms of biosphere or terrestrial mitigation, land mitigation, because a lot of the NDCs include creating additional carbon sinks on land with afforestation or reduced deforestation and so on. We will see how the monitoring, reporting, and verification process is set up in the Paris Agreement. In the meantime, how do you even monitor the fluxes to make sure that there are additional sinks being created or emissions are being mitigated, right? So satellite data is one of the critical tools in this. There are challenges in measuring even above ground carbon, let alone below ground carbon by satellites, especially at global scales. Doing it regionally or locally and in a sustained fashion requires lots of investment as well. So this is a nice paper that came out of Boston University, Professor Ranga Maineni, which used satellite data to look at vegetation change or change in leaf area index from in terms of percentages from 1982 to 2015, and it made plenty of news because it turned out that there are large parts of the globe where actually the leaf area index has increased. And then you look at the details, it turns out that China has actually done that by increased afforestation, whereas in India a large fraction of the increase in the leaf area over this period has come from agricultural activities. So why does it matter? Because there is again the competition between food production, carbon sequestration, and climate change mitigation. So those are the things that one has to monitor. So the key elements of the MRV or the monitoring, reporting, verification framework, it requires things like biennial update reports, international consultation and analysis, and nationally appropriate mitigation actions, which are already part of the NDCs. Kyoto Protocol, which was more of a top-down process and essentially failed, was replaced with this bottom-up approach, more democratic approach, where countries voluntarily submit a report on how much they will contribute to reducing emissions and to mitigating climate change. And once that is done, then you need a process for monitoring that this is being accomplished. So international MRV includes national communications, BURs, and ICAs. So this was done under various framework activities in the Paris the UNFCCC process. There are domestic MRV requirements in terms of determining arrangements for domestic MRV of domestically supported NAMAs or NAMAs. NAMA means something else in India. Nationally appropriate mitigation actions. Report on domestic MRVs in BUR, then feed to the international MRV. So it's a global local interaction needed, because all mitigation is local, right? All adaptation mitigation is local. The impact is global in terms of reduced emissions. MRVs for RED, so that's reduced emission from deforestation and forest degradation. This is now RED Plus, the next phase that's already on. It's voluntary. So report RED Plus results in a technical annex to BUR, which is the biennial update report. So I think the first biennial update report is due in 2023, if I'm not mistaken. But it's not clear to me yet how the COVID business, the COVID lockdowns, the economic impacts, and the vaccination, etc. The pandemic is still very much alive across the world, so how that's going to affect the whole climate action, Paris Agreement, MRV processes, etc. Looking briefly at some of the ways in which the monitoring can be done for carbon. This is satellite data. This is a map of lively woody vegetation above ground biomass across the pan-tropical region. So you can see the satellite orbit limitations cutting it off at some latitudes. This is derived from a combination of multi-temporal MODIS imagery and global land assessment something. You can look it up. Lidar measurements. So like radar, Lidar is light detection and ranging. Co-located with standardized field inventories. So every time you do satellite measurements, you need ground validation and calibration. So the signal that the satellite is measuring is going through the atmosphere. It's going to be affected by dust and humidity and clouds and various other things based on the wavelength in which it's measuring. Like some infrared cannot, for example, go through the clouds, but microwaves can, and so on and so forth. Typically these are what are called hyperspectral instruments. They measure in many spectral bands, which is very useful, especially for vegetation at high resolutions and so on, in time and in space, but the time resolution depends on the orbit as well. Okay, so these kind of equatorial orbits which are cut off at some latitudes can give you higher spatial resolution and temporal resolution, for example. Greens indicate high biomass areas up to 200 tons of carbon per hectare, and brown areas indicate low values less than 30 tons carbon per hectare. Gray areas are unvegetated or outside the area mapped, so these are not mapped. Red boxes indicate so you are zooming in here and looking at the details. So you can see that you can get to very high resolution, which could be very critical for managing the reporting and so on. So life cycle analysis also then becomes important for reporting the additionality of carbon sequestration. This additionality is critical, that it's not just an activity that would happen anyways, that you are doing something extra to meet your commitments to the climate change mitigation. So in biofuel, life cycle analysis could include something like water use accounting, for example. This report here shows how greenhouse gases, regulated emissions, and energy use in transportation is done. So it's looking at surface and groundwater use, including irrigation for producing the feedstock that goes into biofuel production, and the transportation rainfall contributions, discharges, biofuel production discharges here, production of electricity and other fuels and chemicals, cooling processed water and steam used, and the biofuel transport itself all the way to where the biofuel actually gets utilized and the cycle ends. Okay, so the same thing has to go for accounting carbon as well, to make sure that this entire process end to end is actually mitigating climate change. Okay, so how to monitor contributions to land use, land change, and forestry. It needs greenhouse gas inventories. This is showing a detailed example going from effects of key processes on land CO2 sink, including direct human-induced impacts, indirect human-induced effects, and natural effects. Where these effects occur: direct human-induced, indirect human-induced, so over unmanaged land and managed lands. The same for how these effects are captured in the IPCC AR5 protocol or the country-level greenhouse gas initiatives. So obviously, direct, indirect, unmanaged, managed land processes have to be tracked. And then detailed bookkeeping models are required for afforestation and biomass harvested, digital global dynamic global vegetation models are used, bookkeeping plus DGVMs and so on. So negative here, of course, means you are actually sequestering carbon or reducing greenhouse gas emissions, developed countries, developing countries, and globally. And this is for primary forests. This is for afforestation and harvesting. So again, these are forest fluxes, forest area, and forest fluxes per unit area. Okay, so lots of details, lots of bookkeeping required, but it's critical because the only way we can track where the carbon is going and that additional carbon is being sequestered in addition to reducing the emissions themselves is to do these detailed calculations of carbon stocks in the various boxes in the land biosphere. You cannot just use the atmospheric concentrations to see whether indeed the mitigation processes are working. And it's also important to have metrics to see if the full mitigation potential is being reached and how the benefits are being accrued, as well as how other competitions like for water, for land use, food vulnerability, food security, and so on are being affected. So complicated process, but nonetheless this has to go on. This must get better. Countries have to get better at monitoring and reporting and verifying.